This is the application security standard that I would point to my students. Welcome. So in this video we will talk about OWASP top 10, and I'm going to present to you every single topic there is. I'm going to review the original video that I created with a new video. So this is the newest video for OWASP top 10 2024 on my channel. First of all, let's go and search it up on Google. We have the link right here. It's called owasp.org. Go ahead and click on it. When you are on the web page, you know, things haven't changed that much since I created the very first one. It's a very long time ago, and I decided to create a new video now because a new revised version is actually out and has been out for some time. Go ahead and click on the top 10 project, and as you can see, the 2017 to 2021 changed a few things. You can see that the injection part here went down to number A3 and it's just called injection for now. And that is also consisting of cross-site scripting. So you can see that injection these days is basically just cross-site scripting and so on. Now this is the 2021 version, and we probably will expect at some point in 2025 to get a new revised version of the OWASP top 10 series, because every about 4 years time, as you can see, 17 to 21, before that were 13 and so on. So what we really look at here is a revised version of the 2017 to the 2021 version, which consists of these 10 different topics. If you scroll down here a bit, you can read all about the different topics. A1, broken access control. Now the question arises, why is it that broken access control went up from the 5th to the 1st? And why is that injection went down? So what really happened in 2017 to 2021 is that developers started to use frameworks even more. More and more frameworks and libraries being released all the time. And when developers use these libraries and so on, they get certain kind of help through the development process. And that process is what you can see consisting of right here, is that things as broken access control now is basically the biggest threat in 2021 and well, still will be up to 2025. That's going to be a bit shaky to say, because things will develop slowly. So within the 17 to 2021 model, you can probably take a small timeline and you can see that things are rearranging. So I cannot really say whether this is gonna be the 2025 model. How will it look? I'm really looking forward to it. So let's go ahead and review the very first one, called broken access control. First of all, you can see that it moves up from the 5th position, and they tested 94% of the applications were tested for some form of broken access control. Now, what is some form? You know, these kind of things is very interesting. I'm going to get back to that pretty soon. The 34 common weakness enumerations mapped to broken access control had more occurrences in application than any other category. That is very serious. Let's go ahead and click on it. So you can see up here in the index tab that there are different kind of, you know, it's just a factor overall, you know, they are proof of how they found the data. If you scroll down here in the bottom, all the way down, this is the broken access control. We are looking at the A1 right here. Right down here, you can see the list of mapped CVs. It should be around 34 of them. Now, if you check these common weakness enumerations, which you go ahead and check out by clicking on one of the links and read about what is relative path traversal, what is path traversal, what is improper link resolution, and so on. All these different kind of things here is what they put into the category of broken access control. Now, if you want to learn about these different kind of things here, you have to go ahead and click one of them. We can just say stuff like improper authorization. It's a common weakness enumeration number 285. Go ahead and click it, open the new link, and you can read about it. This page right here is a bit more technical and a bit more heavy. It's not like the OWASP top 10 page. This is more like the original OG page that shows all the different things that you would like to know. So if you go ahead and check it out here, you can zoom in a bit, you will see the relationship here, which is kind of the important part, that the child of different things, improper access control 284, and we are on the in 285. That's called improper authorization. So authorization has something to do with access control, and that is the child of the 285. You can go and click that, and then you can continue and say, okay, improper access control. Scroll down a bit and say that is the member of research concept, improper privilege management, improper ownership management, authorization, and so on. So this is a bit more advanced. If we're going back to the 285 one here we have in the top, this page here also will talk about, this is the product. The product does not perform or incorrectly perform an authorization check when an actor attempts to access a resource or perform an action. That is the overall text explaining what this is all about. So scrolling down just a bit, you can see sometimes there are some examples here. There's one here, demonstrative example. This function runs an arbitrary SQL query on a given database, returning results for query. So you can see here that this is the actual run employee query database name, and you can see to select all from a name or evil name. And there is no, well, there's some sort of prepared statement, but this is an actual example. And you can also see, while this code is careful to avoid SQL injection, the function does not confirm the user sending the query is authorized to do so. So thinking about this way, you will actually learn as a developer, well, you can write these kind of functions as you go, but is the user that is using this function here, run employee query, actually authorized to execute this SQL statement? This is a thing because you probably just have a user on your database that have access to, let's say, a particular table. This is the actual connection string, which is fine, but you need to have some sort of way saying I'm logged in as Brian or Susan, and Brian or Susan will be able to do this and that, but not the same thing, which is why you should do some sort of check, and this is what they talk about. So that's pretty heavy, I guess you will guess that now, but that's one of the core differences on the 2017 to 2021. Is that you can actually, in a more easily overviewable way, see the list of mapped CVs. Alright, so scrolling up just a tad here, you can go ahead and check out this is broken access control, going back to the basics, reading the overview, reading about it, description, and there's a small list here of bullet points explaining all the things. How to prevent would probably be the easiest way to start, but I would suggest read it from the top and down. When you read these kind of things, you will find new things like deny by default. If you haven't heard about that before, it'll be something you have to look into, because that is very interesting, very important security principle to develop your software from. Taking a step further, go to cryptographic failure. And this is all about, the first thing to determine the protection needs data in transit at rest. For example, password, credit numbers, health records, personal information, and business secrets. So you need some sort of cryptographic algorithm that is not easy to bend or break. And these kind of things here is what leads to cryptographic failure. Sorry for that. And it's a difficult word for me to say, because you probably hear that. So definitely read all this text here, and you can go ahead and check it out. How to prevent, probably easy enough, but remember that if you're using web applications, which most things are developed for these days, you should always use what you call TLS and always do strict transport security. Well, that's the thing you have to enable in the header. But one thing you probably is wondering about is the actual algorithm you can use to, encrypt stuff with or hash stuff with. For hashing, there are these kind of factors right here: Argon2, scrypt, bcrypt, and pbkdf2. Most of us probably would just use bcrypt because it's proven to be the most effective algorithm to do hashing with passwords for. In most occasions on websites, you probably hash things, and that is really what I would like to say, that pick the things that make more sense for you. So there are also example attack scenarios, and this is the thing that they do really well in the 2021 version, is that they do actually sort out how actual attacks could work, so you can think about it. This is the time for you to step back just a tad and say, hey, so I want to learn about these different kind of attacks. How can I do that? Because just talking about the theory and listening to the theory will make you understand what's going on, but you would need to have some sort of practical way of having tried this in order to understand it on your own person. And this is what I would like to say, and you need the yin, you need the yang. The yin is the theory and the yang is the practical applied, so you do something with it, you do penetration testing. So go ahead and check out my other videos on my channel. I have more than 200 videos about only penetration testing. Most of the things are done on Try Hack Me or Hack the Box. I'm an ethical channel, so you can always make sure that I'm only using safe systems to teach and show you how to do penetration testing. However, you should not take the skills lightly you will learn on my channel, because they can be used for stuff that could be harmful for systems. So please remember to stay safe, and do it ethically. Only hack your own stuff or stuff from Try Hack Me or Hack the Box, for example, to learn it, so you can better understand the different kind of things and vulnerabilities there are in systems. The third one is called injection. We've been there as an old contender, but now injection is more unified by different kind of things like SQL injection, OS command, object relational mapping, or the OAM, LDAP, expression language, cross-site scripting, and so on. All these different kind of things is part of what is called injection now, and you can see down here in the example scenarios, you would need prepared statements and so on. And don't take it lightly that the broken access control is part of this, because if you do have a very good SQL statement construction in your code using prepared statements and so on, you still need to make sure that you have your allowance to execute that particular SQL statement with the user that you're logged in with. Alright, insecure design is a very interesting one also. It's called the A4 one. This is where you focus on risk related to design and architectural flaws. It's a bit more objective, you could probably say, a little difficult just to give a broad example, but this is where you use secure design patterns. You use a way to architect your code so it does things. For example, you get a request from the client, it goes into the system, and there's a certain ladder you go down, if I may use that reference or metaphoric way of explaining myself. So use this kind of a ladder to go down, or like an onion or layered system, however you would like to. Also, if you in your design work out from deny by default, so you say, well, you have no access, so you have to prove to me that you have access. So if you work from that confidential model that the user have to prove themselves that they have access, that's the way to go for example, a secure design. So insecure design here is talking about these different kind of things. Definitely go ahead and check it out. It's very important when you're a developer. A5, the old contender, security misconfiguration. It's a thing. It's gonna be here forever. People gonna forget to close unnecessary ports, services, and stuff like that. Delete pages not used in replications, have the right privileges, default accounts, bad passwords, error handling, stuff like that. Many different kind of things, And there are also, again, the example attack scenarios. A very, very interesting and very, very important text to read here on OWASP. going to A6. It's called vulnerable and outdated components. It's the thing. Okay, so let's take one step back again. So you still need to think about how can I think about this standard in a way? How can I use it, right? So my best suggestion to you is that you read about the 2017 model for security for OWASP, because the things in the 2017 is still existing. It doesn't mean that just because it's say 2021 to 2017 that 2017 doesn't exist. Basically just means that, well, they created a more categorical way. So this is what you see the OWASP categories are doing right now from the 2017 to 2021. Is where they created more, we could say, foundational categories called, for example, just injection, like design stuff, you know, the insecure design, security misconfiguration. Some of the things already exist. What you saw in the old model is like things had different kind of, you know, for like SQL injection and cross scripting. And why is it, you know, and I want to stress it one more time. The reason why you don't have these subcategories that are on the same category, for example, SQL injection and cross scripting should just be called injection. It's because developers are using more frameworks and more libraries that kind of take care of these things like cross scripting. The browser also, different kind of browser, you know, brands you can get these days like Chrome, Firefox, and so on. They also have cross script mitigation installed. So it's very interesting how they combat these kind of things. A7, identification and authorization failures, talking about previously known as broken authentication. This is where, for example, permits automatic attacks, such as a credential stuffing, where attacker have a valid list of username and password. Permit brute force and automatic attacks and so on. So when you are developing your web application, you're making sure to write your software or in some way put something in front of your application that can detect these kind of things and stop automated attacks, and that will actually make it a lot better. In the old days, people probably put something in between called a web application firewall, and the web application firewall will be pretty good, I guess, or the WAF, web application firewall. But it's not a one-click install solution to everything. Definitely have to think about what is my context in my application, what is my kind of attacks, what should I be protected against, and so on. You cannot just take a standard product and roll it out and say, so I'm done. Alright, so number 8, software and data integrity failures. Integrity is, let me just find a new category, focusing on making assumptions related to software updates, critical data, continuous integration, continuous delivery pipelines without verifying integrity, one of the highest weighted impacts from common vulnerabilities. So they are talking about software and data integrity failures related to code and infrastructure does not protect against integrity violation. Talking about integrity is basically where you can in some way alter the state of whatever we're talking about, the data, the model, the database. So you have to use some sort of digital signatures to prevent this kind of mechanism to not verify the software data from the expected source, not to be altered and so on. So talking about integrity, it's all about when you think about the CIA tried for confidentiality, which is the actual access part of it of data. Think about the categories here, which is confidentiality. You know, think about these kind of questions because that's very important for web application security that you just stand the CIA triad. It's very easy to talk about, and it is the ground foundational pyramid for the 3 security goals everyone should know. Integrity is where you alter something. The state is different from what you expect. So security logging and monitoring failures is basically what I say people forget too much about. You know, if you don't have security logging and monitoring, well, what happens if you get hacked? You cannot get back to business as usual, or can you? Because the problem is, if you cannot fix the error or the flaw, you will probably just be compromised again or hacked, whatever you want to call it, and that's really not the thing you want. So please make sure to have a good logging and monitoring going on. bringing the last one into is the server-side request forgery, and it's a lightly one. It's only one CVE mapped, and this is the category where serve flaws occur whenever a web application is fetching a remote resource without validating the user supplied URL. So this is about validation. So basically read the sentence the way that I read it right here. So we have something called server-side request forgery, or serve. It occurs when validation is not happening. So please validate your URLs. Your data from the client is evil. You cannot trust. This is the way you have to think about it. So always deny by default. Back to the basic again. It's one of the most important things in web application architecture, is to make sure that you have validation and sanitation. It's actually right here. So you sanitize and validate all client data inputs, enforce URL schema port destination with positive allow list. So you say an allow list, don't do blacklist, do whitelist. And whitelist is basically reversed of a blacklist. So whitelist say you can do this. And that will basically deny everything else. So that is denied by default with some sort of way of saying you're allowed to do something, but no more than that. If you want more access, you have to prove yourself. All right, so if you want to go next, I have a next step right here, and the next step is the A11 by design. Every OWASP top 10 has a on the cusp risk considered length for inclusion. Alright, so you can go ahead and check out the next one here, and that is called the next steps. And looking at this, they are talking about stuff like denial of service and memory management and so on. And that is a bit away from most web application development. So I want to say from the OWASP 2017 to 2021, we do have a big difference that we talked about right here. So I kind of hope that, you know, the 2025 version will have a more standardized way to talk about it, because I think they came a long way by creating a better way of categorizing the things, because I feel the 2017 and even before that 2013 model were a bit confused from the original creators from OWASP, because they lacked the categories. So they get better, and I think the 2021 model is actually pretty good. Soon I'm gonna create a 2025, gonna be next year at some point. It should probably be around a year from now, and I'm gonna create a 2025 revised version, because I kind of think this is where they will take it next. But wait, there's more. We should not end this video this fast, so going back to the OWASP page, I really want to make sure that you understand that web application development is kind of important and serious business. Going to projects one more time, and then browse all projects and scroll down just a tad. You will get an overall overview of everything they work with. What I want you to think about is there are some requirements for your web application. It's called the ASVS, the Application Security Verification Standard. That is their take on an actual standard. Go ahead and check out the release. I think you can go ahead and check out they should have a link here somewhere down there. Stable downloads, and take the English version here at the top, and then you're gonna check out the OWASP top 10 application security verification standard version 4.0.3. It's the final one from October 2021. The document here is all about, I think it's 14 different categories, from V1 architecture, design, threat modeling, authentication down to the, I think it's the 14th one we have. Let me just find it. Yes, so down to number 14, that should be it, yes. So 14 different versions, categories of web application security, configuration, and development rules. If you're going to go ahead and check one out, let's say you're going to take out, file upload on the V12 like that, you will get these kind of rules right here saying verify that the application will not accept large files that could fill up storage or cause denial of service. So why is that? And this is the things you have to think about really carefully, because following these kind of rules when you develop some code, you can understand this. This is plain English. Some of it is probably a bit out of maybe some of your way of talking, but basically these days we have ChatGPT, so you can just put it in and it will basically explain to you. But what you see here is called L1, L2, and L3, different kind of security levels, which you can read about up here in the top. And I highly encourage you to read this document here, understand what are the different levels all about. Level 1 should be all applications. Everyone should do that. Everyone should be low assurance. And this is also called what is completely penetration testable. A2 is for applications that contain sensitive data which require protection and is a recommended level for most applications. So I want to say you are probably there. You are probably on level 2, because it's very highly improbable you're the only level 1, but it might be possible. If you're level 3, you are very serious and probably a bank or a big company, that really have some critical application going on. This is the application security standard that I would point to my students if they ask me, Daniel, how would you develop a secure application? I would say, well, you need to understand the OWASP top 10 practice first, and then you need to understand the ASVS, application security verification standard, and then you can go on and try and do some safe coding. So that's all for now. I really hope you learned something for this video. If you wish to support me, there's a link description that's going to take you directly to a place where you can support me and this channel. I will create more content all the time about security. Stay safe and make sure to be ethical in all your things you do in life, especially when it comes to online security. Have a nice day.